Hello and welcome everyone to our second Adoptium Summit webinar series. My name is Serena and joining us today is Pushkar, who will be presenting on the topic of how we did TCK with Eclipse AQAvit. If you have any questions for Pushkar as we move through today's presentation, please feel free to put them in the chat or use the Ask a Questions tab. Without any further delay, Pushkar, over to you.
Thanks, Serena. Hello, everyone. Uh, Good morning, good afternoon, good evening, wherever you are in the world. So today's talk is about how we did TCK with Eclipse AQAvit. Now, uh, what is TCK? What is Eclipse AQAvit? We'll come to that. But this is an experience sharing talk. This was first presented at the OCX conference, the Eclipse Foundation's OCX conference in October last year in Germany. And then we thought it would be good to have it presented in this Adoptium Summit series as well. A little bit about myself. I'm Pushkar Kulkarni. I'm from India. I work for Canonical, which is the company behind Ubuntu. Before Canonical, I have worked for quite a long time with JVM technologies. I think starting from the days of Java 1.4.2. So, and this was the first time, the last year was the first time I started looking at the Java TCK. So it was quite a nice ride. So I will get started. The agenda looks long, but um, it's quite, I think, digestible. It's not actually long. It's quite short. So first I will start with OpenJDK for Ubuntu, then move to why TCK is important for us as a company and for Ubuntu as an operating system. Then talk a little bit about TCK, the OCTLA, then move to the core of the talk, which is Eclipse AQAvit, and then share the actual experience of using Eclipse AQAvit um, to do TCK. I will, though I have demo at the end, I have actually included two demo videos in between the slides, just so that the demos come in the right context and that we don't lose context by showing demos in the end. Yeah, so OpenJDK on Ubuntu. So if you're not aware, Ubuntu offers all the current LTS OpenJDK releases, OpenJDK 8, 11, 17, and 21. They are supported on all stable Ubuntu releases. By stable, I mean the LTS releases. So right now it's 24.04, 22.04, 20.04. We also have some extended maintenance for 18.04 and 16.04, and OpenJDK packages are also available on these. But that's only for customers who have opted for extended support. We do the quarterly OpenJDK security updates that are published by OpenJDK, and these are published on all our current Ubuntu LTS releases. We also have development releases like Ubuntu 25.04, which will be out this May, will have early access OpenJDK 24. We support um, all the popular architectures that Ubuntu supports, of course: AMD 64, i386, ARM 64, ARMHF, which is a variant of the ARM 32 architecture. Then there is PPC 64, S390X, and even the RISC-V, which is turning out to be an interesting one. Apart from the OpenJDK packages, we have some Java-related tech. We have something called chiseled container images, which are really small container images for Java. We have a FIP solution. We have a Spring Boot solution as well. And we also have OpenJDK checkpoint restore packages for version 17 and version 21 starting 2014. So let's take a step back. So Canonical has an open source commitment. So we promise that innovation platforms should enable everyone to participate and consume technology, and bringing open source to everyone in a reliable and cost effective way is what we look forward to. The word reliable is, I would say, quite loaded there, but to keep it simple, I think the promise of reliability of software has two aspects which one cannot compromise on. The first one is correctness, and the second one is performance. That is the desired performance. Traditionally speaking, correctness should come before performance, yes, but I think when we talk of reliability, correctness and performance should go hand in hand. This talk is more about correctness than about performance. So let's look at what correctness means to us. So, talking about correctness, there are a few questions which we asked ourselves. And here I'm saying talking about correctness of our OpenJDK packages. How can we instill confidence in users about the correctness of the OpenJDK packages on Ubuntu? Because it's an open source project. It's yes, it is spearheaded by a bunch of companies, and yeah, that should instill confidence. But still, when you are shipping a binary, why should a user trust that binary? Second one, how can we make a formal claim of correctness? And in this context, that formal claim could be made if we fully comply with a formal specification. Now, do we have something like this for Java? And the answer is yes. It's called the Technology Compatibility Kit. That's what TCK stands for. Um, yeah. So this is a very basic, a simplistic introduction to what the TCK is. So in Java development, you have everything starting with a JSR, which is a Java specification request, and then you have an implementation of that JSR. Now, every JSR makes certain assertions, and those assertions need to be tested. So, those assertions are encoded as tests in the TCK, and the TCK asserts the correctness of that implementation. So, it's a quite a simple depiction of where the TCK sits in the Java community process. So, it's a compliance suite, test suite, to uh, say in simple words. Um, TCK material, if I may call it, is offered by Oracle Incorporated through a license called Open Community TCK License Agreement, or it's commonly known as the OCTLA. So if you go on the OCTLA homepage, they give you a list of signatories. For example, you can see Canonical listed uh, in both signatories for Java SE9 to SE20. We signed up for OpenJDK TCK for OpenJDK 17 as well as TCK for OpenJDK 21. So the starting point, if you have your own OpenJDK binaries and if you want to have them TCK certified, is to get in touch with Oracle and make sure you sign the OCTLA agreement. Once you have signed the OCTLA, you get access to the OpenJDK material. The TCK material from Oracle. So there is going to be a package for OpenJDK 17, a package for OpenJDK 21. If you've opted for other OpenJDK releases, there are going to be different packages for each one of them. But just with that package, it is really, I would say, difficult to get started, to get bootstrapped, because that package has test cases, it has a test harness, it has some configuration files. And getting started, getting bootstrapped is, to my understanding, it's not easy unless you have expertise in your team who have already worked on that, because you need to define test targets. You basically need to divide that entire test suite into smaller targets and then groups of targets and then targets which point to larger groups. That's one challenge, defining the test targets. The second challenge is compiling the tests. The instructions might not be very clear to everyone. And the third one is configuring and running the test harness. So these three things are not at all trivial, and they need expertise. Also, um, it is very likely that JDK distribution. So if you are a JDK distribution, you might want to fit all of these testing activities like functional testing, regression testing, security testing, compliance, performance into one single framework. So you might want to run, so whenever there is a new OpenJDK release, you might want to run a pipeline or parallel pipelines of these different test suites, and TCK is just one of them. Um, so that requirement for a uniform framework might also be there, though we didn't have anything of that sort. What we were in search of was a simple TCK test framework that abstracts the TCK test harness details, that doesn't require us to work with the, I would say, the complicated or with the very involved um, test harness and configuration files which come with the TCK material. We were also looking for an easy to use interface which would help us get started quick, because we didn't have the liberty of a team of people working on this. There was just me and another colleague of mine who's also my manager, and he was involved on a very limited basis on this. So essentially it was just me working on this. So uh, anything that would help us get started quick was what we were looking for. Our next requirement was that uh, it should have helped us. It should help us to build more automation, because ultimately we would want to run TCK as a pipeline, which is auto triggered. So that's the end goal. So anything that enables this automation, that lets us build layers of automation on one on top of the other, that's what we were looking for. And the last requirement is, yes, we were looking for an open source solution, because we are an open source company. And when I say open source, yes, we do expect that there would be a community to support, and to also contribute towards, look for support and to contribute towards. And turned out that the Adoptium community, which comes under Eclipse Foundation, was what we were actually looking for. Um, and AquaVit was I should say, the project that helped us in getting started with TCK. So, in short, Eclipse AQAvit is not restricted to TCK, as I mentioned on one of the past slides. It helps you with functional regression, security, performance, all kinds of tests. It's very easy to use. I'll show a demo of why I say that. It offers good abstraction and control at the same time. Yeah, there is evidence for this as well. So there is good abstraction. I mean, you can get started in under 5 minutes, but then you also have fine-grained control if you want to use it. There is a great developer community. I have on multiple occasions reached out to on the Adoptium Slack channel, and received great help, timely help. It encapsulates years of TCK and JDK testing experience. So I do come from a JDK development and support background. So in the past I had colleagues who used to work on TCK and the different test activities for the JDK, and I know how much expertise is involved in this activity, and aquavit encapsulates all that expertise into a bunch of scripts and configuration files. And it also helped us to focus on the higher layers of automation. So automation, in my view, happens in layers. So Right now, we've just built one layer of automation on top of AQAvit, but where we want to get to, I think that will need a few more layers. So anything that could give us that abstraction on which we can build more abstractions, we were looking for that kind of a framework here. The entry point for us for Eclipse for Eclipse AQAvit was the AQA tests repo, which is under the Adoptium organization. And this in this picture, you see what I was talking about. AQA tests comes in picture in this test phase where it can run various kinds of tests. It can help you run various kinds of tests: OpenJDK, functional testing, system testing, external performance, and JCK. By the way, JCK and TCK are kind of interchangeably used. So JCK is the same as TCK. And these may be run, one after the other, serially or parallelly. That depends on how you want to run them. So getting started, yeah, I might repeat a few things. So we had almost zero, or you can say we just had knowledge about what the TCK is or what JDK testing is like, but we didn't have any testing experience on the team. So Canonical signed the OCTLA with Oracle and joined Adoptium in somewhere around, I think, June or July of 2023. The initial pilot TCK 17 run, once we got access to all the, you know, the community and the resources, the initial run on my laptop took hardly, I think, less than an hour to get started, and it took a few hours to complete. Yeah, some tests did fail, but that initial run was so easy that it instilled a lot of confidence in me, because from my past experience, I knew what GCK and what TCK is, and I knew how hard it was to. So I was a developer. I was given TCK bugs, so I knew how hard it was to just isolate a test case from that TCK framework and make a independent reproducer out of it. So I was really anxious, but uh, going through the AQAvit, the AQA tests, their instructions, and running TCK, it was so easy that, yeah, I was really happy that day. I still remember that. The documentation on the Adoptium AQA tests repository is also quite helpful. It is a little fragmented. You might need to search a bit here and there, but yes, everything that you need is there. That's what I have realized. In the beginning, we also did a Docker container pilot, which means we also tried to run OpenJDK, I think TCK 17 against OpenJDK 17 in a Docker container. That also went well, but we eventually decided to move to VMs because I think that was more suitable to what our infrastructure was offering us. So I think this is a good time to watch a short video about how you can get started with um, Eclipse AQAvit in under 5 minutes. So I will I will assume that you have. I mean, this video assumes that you have the TCK material which is available under the OCTLA downloaded. So I'll just hit the play button now. I'm going to give it a voiceover. So here I'll just pause for a moment. So when maybe I should do a full screen. Yeah. So you see a directory called TCK21 here. That's the TCK21 test material from Oracle received under OCTLA. Okay. So what's the Java version here? So I do have Java 21 installed, and I'm going to initialize Java home with the home directory of that installation, which is this is a Ubuntu specific path. It need not be the same for on your OS. And now I'm going to install some dependencies which we need to run TCK, make GCC and contrib. So before running TCK, you need to compile the entire test suite. That's why we need these dependencies. Okay, now I'm going to clone Adoptium AQAvit. That is AQA tests here. Okay, that's done. So now I cd into AQA tests, and now there is a script to run called get.sh. This also pulls in the test kit gen repo and some other repos which are needed. Yeah, you see, oh, sorry. Oops, I pressed the wrong button. Yeah, so running get.sh again. So get.sh has downloaded a few more scripts which we need. And now I cd into the TKG directory and then set a few environment variables. The first one is JCK git repo. I'm going to be pointing to the TCK21 directory. There's going to be a second one which also points to the same. I'm not sure why we have these two, but yeah, you need to define JCK root as well, and then you need to define build list, which just has JCK because we are not running any other suite, and then point to the test JDK. So in this case, it's the same JDK that Java Home points to. And now, for the sake of this demo, I am going to be running the Java math target. Oh, before that, we need to compile. So there's a make compile. Now this is compiling all the tests. There are some .c files there as well. So that's why we installed GCC. So the compilation is done. And now, yeah, now I'm going to set a custom target called JCK runtime custom target and initialize that to API Java math, which means just the Java math tests from TCK would be run. And then I just say make JCK runtime. By the way, all these instructions are available in the readmes in the AQA tests repo. Yeah, and the tests are running now, and they have passed. So you saw in under 5 minutes, I was able to get started and run, one of the test buckets of the TCK. Yeah, and you have the artifact generated there, the JTR files. So I think that That demo video conveyed the message of how easy it is to get started uh, with TCK. Without this framework, I cannot imagine how much time it would take to do this kind of a bootstrap. So let's talk about the initial infrastructure challenges which we faced, and these are, I think, quite specific to to our environment, to our case, and they may not be something which might be common elsewhere. But I will talk about those challenges and then talk about how AQA tests helped us, or AQAvit helped us. So we started with a very basic scripting support. Um, on top of AQA, we wrote some basic wrappers which would help us, um, run the tests and move the artifacts to a desired location, and then report progress, and all those basic things. We started with formal TCK 17 and TCK 21 runs on OpenStack VMs. We had chosen them over Docker containers. The initial focus was on certifying 17 and 21 on AMD 64 and ARM 64 for all Ubuntu releases, LTS releases, including 2404. So this was during the development cycle for 2404. We had targeted certification of our OpenJDK 17 and 21 packages on AMD 64 and ARM 64 for Ubuntu 2004, Ubuntu 2204, and Ubuntu 2404. Uh, what uh, what we were faced with initially was a very serious storage limitation on our local OpenStack instance. Again, this was crazy. It's resolved now, but it was a very serious limitation then, and we had a very limited disk space, and running the entire TCK would just not be possible because the the artifacts that it generates, well, those are quite important because TCK is a self certification. Yeah, it's a self certification, and you need to maintain these artifacts as evidences that your OpenJDK binaries or your JDK binaries are TCK compliant. So it's important that you maintain these test artifacts somewhere. Um, but the amount of test artifacts that were generated, it was simply not possible to have them on the volumes that we had, and we had a serious shortage of volumes. Again, as I said, it was quite a crazy limitation, and I don't anticipate that anybody else would face it. But what helped us here was, so if you go to the AQA tests manuals, you'll see that it's TCK is divided into sanity. So there is a target called sanity. There's a target called extended. There is a target called special, and then I think there is a fourth target called dev, which are not really those tests are not uh, really necessary for claiming compliance. But we were looking at uh, sanity, extended, and special, and these totally comprise around 150 targets, and running all of them would produce somewhere around, I think, 30 GB of artifacts, if I remember it well. And because of our limitations, we did not have that much of a space on the volumes that we were given on each VM. So because AQA, defines these small targets, 150 targets, we were able to run one target at a time, stash the results away, run the next target. So it was possible only because AQA gave us that fine-grained control. At the it is like it is abstracting a lot of the details, gory details, but at the same time, it is giving you some fine-grained control. So yeah, this may not be a problem everybody would face, but we faced it, and we got help from AQA there. Of course, some compiler test targets do demand a good amount of physical memory, though it's my impression, and I've also heard from Oracle that Um, there are no resource requirements. There are no minimum resource requirements as such for running the TCK. But in my experience, we did see some tests failing because of a lack of swap space. So configuration of increasing the swap space helped us, and those failures went away. Again, the help came from the Adoptium community there. There are some tests which need external services. This was another point where I was a little confused about what was happening. So the UI tests will need a VNC server, and I'm not talking about the interactive tests, which we will come to later. These are automated UI tests which need a VNC server. I think setting up a VNC server was not difficult, but the next 2 points were somewhat not clear. Some of the Java net tests need an FTP server, and that FTP server configuration also needs to be provided. And some of the security tests need a Kerberos server, and supplying that configuration is what was not straightforward. But because of help from experts in the Adoptium community, we were able to set these external services up and configure them. There are a few tests which reach out to um, external HTTP, HTTPS URLs. So if you are using an HTTP proxy, which we are now very recently facing, the new infrastructure given to us mandates all connections through a proxy. So there are these external connections which the tests make. So if you're using a proxy, you might need some configuration there. But as long as you know what to do, I think doing it is not difficult. You have all the support and help. So yeah, as I said, setting these services up and then configuring them with AQA was a good learning exercise. I think I went through a few iterations of help with experts from the Adoptium community there. Yeah. Um, so we had decided to run tests on 17, OpenJDK 17, OpenJDK 21, and then on three Ubuntu releases and spanning 5 architectures. So the minimum number of VMs which we would need was 20. Um, Finding VMs was or getting VMs commissioned was not a problem, but managing all we did not. So when I say we, it is just me. So I did not want to manage so many VMs. So similar to the Docker container pilot that we did in the beginning, we also decided to do an LXD container pilot. So LXD containers are uh, they're system containers, quite popular in the Ubuntu ecosystem. So when I say I can use an LXD container on Ubuntu 2404, for example, I can spin up an Ubuntu 2004 container, an Ubuntu 2204 container, or even an Ubuntu 1804 container. And it's not like a VM because it is sharing parts of the underlying kernel. So we thought of using LXD containers as the environment to run TCK, and then we wrote some scripts, and it was quite easy to move TCK execution to LXD. So by doing that, we reduced the number of VMs which we needed to maintain by almost a factor of 5, because now we just needed one VM per architecture, and not per architecture actually, because we could run i386 containers on AMD64, and we could also run ARMHF containers on ARM64. So we just had to maintain VMs for AMD64, S390X, PPC64, and ARM64. So that's just a very short introduction to LXD system containers and how they differ from virtual machines. So in the case of virtual machines, there is a hypervisor sitting in between the virtual machine and the host OS kernel, and every virtual machine has its own copy of the kernel, whereas system containers have a single host OS kernel and they share that. So I mean, you can imagine that the host OS kernel is Ubuntu 24.04, and then there is one container that is running 20.04, another container that's running 22.04, and the third container that's running probably 25.04 also. So that's how LXD containers work. Moving to LXD containers needed some scripting support, but yeah, I think that was hardly uh, a day's or uh, work which was worth a day or two. LXD support helped us extend TCK to the ARMHF architecture. So ARMHF is a variant of ARM32. Ubuntu ARM64 supports running ARMHF LXD containers. So we are currently running these on Raspberry Pis because on VMs we came across a, a, a serious, I should say, bug outside of OpenJDK, of course. So that made it impossible to run TCK for ARMHF or on ARMHF on VMs. So we moved to Raspberry Pis, but we are now contemplating dropping ARMHF as an architecture on which we want to certify our OpenJDK binaries, because I think it's quite rare to find someone using Java on ARMHF. So, I mean, that's still a consideration. Running TCK in LXD containers was quite of a infrastructure optimization, but it also makes the next round of automation easier. And the best thing about moving to LXD was we discovered a JCK test bug, which was acknowledged by the JCK team in Oracle. So, yeah, I think this is good context to show you a very small demo of what it means to run TCK in an LXD container. Unlike the first demo where I did not use any custom scripts, I do use a custom script here, but I am on Ubuntu 20. I think in this demo I'm on Ubuntu 24.10, but I'm running TCK for OpenJDK 21 on Ubuntu 20.04. So yeah. So run TCK is just one of our wrapper scripts, and it's saying it's pointing to LXD TCK 21 focal AMD64. So this is an LXD container which we have built. It has all the TCK material and all the packages needed to compile TCK and run TCK. Also, the binaries which we're going to certify, all of them are baked into this container. And I'm going to just run the same target, though here the target is the definition is as per the AQAvit definition. And I'm just going to give it a directory to save the artifacts at. Okay, let me run that again. This is a short video, so should be fine. Yeah, so this is 24.10 and I'm running TCK for Ubuntu 20.04, which is why it's called focal there. Yeah, and see, it started the container, it ran the test, and then it stopped the container. And of course, in this video, I don't show how the artifacts are made available, but they should be available here after every test is run. So that's just to show what execution in LXD containers means. It's, I would say, the next level of automation that we did, and then we have some plans to build on top of this. Yeah, I think I can go to the next slide now. Yeah, so RISC-V is an architecture that we are very much interested in, and OpenJDK on RISC-V does not have, it's not a full-blown OpenJDK with hotspot. It has the I think the zero JRE, but it is something which can be TCK certified. Um, that's, I think that's quite a clear target of the zero project, that it should I mean it should produce binaries that are TCK certified. Right now we are running TCK on a RISC-V board, and I'm using LXD containers again on that RISC-V board. The different services, FTP, Kerberos, VNC server, are running in a separate LXD container running on that same board. There are some automation challenges here because these boards are kind of disconnected from the rest of the infrastructure. So in future, if we want to bring together all our TCK test runners, then it would be difficult to plug in these boards into that framework. But there we do have an alternative of using using QEMU. So we have RISC-V emulators on which we can run these tests, but that would mean that we would have to trade a lot of performance. So just as an example, so right now on a board, the full TCK takes around, I guess, 8 to 10 hours. But on the emulator, it might take anywhere between a day or day and a half. So we haven't yet decided whether we want to continue running it on the board or we want to use an emulator. As far as my knowledge goes, it should be fine to run TCK on emulators, but I think we might uh, want some confirmation on that point as well. Yeah, because I'm not sure if the emulation part there would be a problem when it comes to certification. But anyway, that's something we would be looking at in the near future. Right now, we are doing it on bare metal. Yeah, so this slide is about the future work that we hope to do and contribute back to the Adoptium community. So I think the the priority here is a dashboard and a generic artifact store, which can help you view your TCK test history, and it can help you access artifacts on demand. So today if I want to fetch artifacts from the OpenJDK 21 updates from say January 2024, they should be available to me on with just a click. I mean, I need not go and run the tests again. Yeah, so that kind of a dashboard and a store to save these artifacts is what we are hoping to work on. We haven't started any work as yet on them. We also want to have TCK run as a part of a pipeline, and it needs to be fully automated. For now, it is manually triggered. I think the next step would be to, uh, you know, trigger it on the click of a button. But eventually, we want to get to a point where the TCK run is pipeline driven. Yeah, that would need more layers of automation. The third thing is there are some interactive tests in TCK which need to be run manually. So we are so we would like to have them automated, but I think there is some discussion and work already happening in the Adoptium community, and we would be eager to contribute to that. And I think that's pretty much of what I had. Yeah, if there are any questions or any comments, I would be glad to hear them.
Let's see. Let's check this out here. So we just have a hello from Indonesia. We do not have any questions, Pushkar, at the time. But at this moment in time, though, I wanted to say thank you so much for the excellent presentation. It was very informative, and if there is any further questions, and it comes in a little bit later on, what I can do is I can certainly send them over to you via email. And this way we can respond and get that to the individuals. So that is it. We will be posting this video recording on YouTube, so feel free to share it across your social media channels as well to get the insight out there from Pushcard's presentation. Well, it doesn't look like
Thanks.
anything else. Thank you so much, and you have
Thanks.
yourself a wonderful rest of your day. Take
Thanks,
care.
Serena. Thanks for the help and thanks for facilitating. And thanks, Eclipse Foundation, for this opportunity.
Absolutely. We look forward to many more. Please feel free to submit some other talks. You take
Sure.
care.
Bye bye.
Thank
Have a
you.
good day.
Bye, you as well.